to do the integration.
For the integration, sir, we have.
Okay.
Sir, I don't have very good idea because, sir, I know about the differentiation. Sir, integration I think means that we are adding the we are adding the non-discrete value. We are adding the non-discrete values like that.
Okay. So let me share whether it is shared or not here. Just not shared, I think. Okay. First of all, you see this one. Integrated rate equation. We are going to see this one. This is the integrated rate equation. First of all, they are explaining the meaning of integrated rate equation. Here saying we have what we have. We have already noted that the concentration dependence of the rate is called the differential rate equation. So you are changing the concentration, the rate will change. We have already noted that the concentration dependence of the rate of differential rate equation. So when we are changing the concentration 2 times, order is going to be changed, rate is going to change. So sometime it was the R2 was becoming that is 9 times R1, or the R2 is becoming that is 1 by 4 times R1. This is when you increase or decrease the concentration, the rate also vary. So that is what they are talking about. Now, the second point, you see what the point is there. It is not always convenient to determine the instantaneous rate as it is measured by the determination of the slope of the tangent at point T in the concentration versus time plot. So sometimes what is happening, there are three types of reaction we study. That is what the equation we study, that is the instantaneous reaction. And that they are saying instantaneous rate we are determined by the what is the slope. At no, they are saying determination of instantaneous rate as it is measured by the determination of the slope at point T in the concentration versus time plot. Now, the another point saying this makes it difficult to determine the rate law and hence the order of the reaction. In order to avoid this difficulty, we integrate the differential rate equation to give the relation between directly measured and experimental data. So why we are doing the integration of reaction here they have given. Okay. Earlier, what is instantaneous rate of reaction? We were determining by the slope of reaction. Okay, slope of the graph between the here what is the concentration and time. But now to avoid this one, to avoid this problem, what we are using, we can integrate the differential rate equation to give a relation between directly measured or experimental data. That is concentration at different time and rate constant. See here another thing. The integrated rate equation are different for the reaction of different reaction order. So for the zero order, integrated rate equation will be different. For first will different, second will different. Sound is coming, Sanoy. Sound is coming from your side or from my side.
Sir, my side should not come, sir. I am going, sir. I am closing the door, sir. Then sound
No,
should
no,
not.
not that sound. My own sound is coming back, reflecting back.
Your sound is reflecting that.
Uh,
So now also coming. Now also
no,
coming.
no, no, no.
Sir, actually, this is having the external microphone and external speaker, no? So that is why it was the
Okay,
problem.
okay.
Sir,
We
if I
shall
make the volume loud, then it will come.
okay. We shall determine these equation only for the zero and first order reaction. So in our syllabus, it is the zero and first order reaction. So we are going for the zero order reaction. So problems comes on this one. So slowly you need to understand this one. Integrated reaction of zero order reaction. Here see what the point are there. See, zero order reaction means that rate of reaction is proportional to zero power of concentration of reactant. Consider the means rate is equal to, if you are writing rate is equal to or the proportional to concentration of reactant power, what is going to be zero. Getting my point? This is the zero order reaction. Another, you remove the proportionality constant. So this will be proportionality sign, then K R power 0. Getting
Okay.
this is zero order reaction. Yes or no?
Yes, sir.
Any quantity power zero. Any quantity power zero means what? Suppose 100 power zero means what? Yeah, 1 lakh power zero means what? What do you mean by this? Any quantity power zero is unity. Understood? Any quantity power zero is unity. So it is going to be 1, it is 1, it is 1, anything. So rate, I'm writing in the rate in the different form. How can you write? In the term of reactant we are writing. So that is negative sign. So what is going to be? dr. This is going to be dr by what is dt. Change in concentration per unit time is equal to k into 1. K into 1. Can we write like this? Yes or no?
Yes, sir.
Now, here you see dt, I am sending that side. So d concentration of R is equal to k dt. Can we write like this? Yes or no?
Yes, sir.
Now, dr is equal to, I am sending minus sign this side, k dt. This is equation 1. Now we are, see, integration of, you must be knowing, integration of what, that is dr is equal to, this is going to be r, integration of dt is going to be t. What do you mean by this? You are adding the small dr, then again small dr. So little change you are adding together. So it will give what, that a complete r, total r. And similarly, if you are changing dt plus dt, so small time interval if you are changing, so it will become full t. Getting? So integrate, you integrate. This is the rule you must be knowing. I don't know whether you know or not. So integrate equation 1. Integrate equation 1. So what will be there? Integration symbol dr equal to minus k. Constant cannot be integrated because it will give the same value dt. So what the term you are going to get here, r is equal to minus kt plus I. When you remove the integration symbol, it will come the integration constant come. This is the integration constant. Integration constant. Can you understand this? Hello? Hello?
Sir, I can understand.
Okay. Now, if time is equal to 0, if t is equal to 0, if t is equal to 0, so if t is equal to 0, so from equation, from this one equation you can consider to be 2. So from 2, so concentration R is equal to, it will be the initial concentration R naught. R is equal to R naught. And T is equal to 0. So from 2, from equation 2, what we can put here at time t, if I will writing at time t is equal to 0, so r is equal to r naught. So here I am writing from equation 2, from equation 2. So at the place of r, I am putting the r naught. For what? Time t, r naught is equal to minus k, time is equal to, I am putting 0 plus I. So this term will become 0. So R naught, here is what I am writing. R naught is equal to I. This is equation 3. From 2 and 3. From 2 and 3. So from 2 and 3 you are going. So I value we are put the value I in equation 2. Put the value of I in equation 2. In equation 2. So this is the square bracket is there. So R is equal to minus KT plus R naught. This is R naught. Okay, here. KT I am taking this side, another side. Otherwise, one graph you can plot here, Sanay. Y is equal to mx plus c. Mx plus c. one graph. Firstly, we are making the graph. You see, if you are matching, this is C is intercept. This is the intercept you must be knowing. Intercept. Okay. M is what is slope. Slope. At x-axis, you are going to take T, and y-axis, you are going to take concentration. So please see this one. This is going to give positive slope or negative slope. Can you hear me? Can you hear me?
Sir, audible only. Audible.
So what is there? Slope is M value. Can you see this one? M value is negative. So slope is what will going to be? Negative sign like this. And initial concentration, this line is representing the R naught. This is R naught. And here is a slope you are going. Slope is equal to, it is what? Minus K. Slope is equal to minus K. So this is what the graph, because your graph sometime asks. This is equation number 4. Of 4 we are rearranging. Okay. So KT is equal to, KT I am taking this side. So it will be the R naught upon
Sir, after
minus.
you are done with this one, sir, can you do one thing like, sir, the everything that all the board work you did, sir, regarding this one, sir, can you just take 3 photos and send me in the WhatsApp? There are sometimes I got interrupted, so I will just check if I miss something.
No, whatever you are saying, nothing is audible to me. Nothing is, it is.
Now audible.
I don't know whether my side problem is or your. Now you tell me what you are saying. Hello? Now you can tell. Hello? 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 Hello?
Disconnected, sir. I think our internet is not running. Sir, I'm trying once again.
Okay, okay, try. Mhm.